All right, chemistry students, here is your corrections for ChemQuest 18, electron configurations. Again, remember that we've talked about this, about these quantum numbers, okay? So the energy of sublevels. Each sublevel has a different amount of energy. For example, orbitals in the 3p sublevel have more energy than orbitals in the 2p sublevel. The following is a list of the sublevels from lowest to highest energy. To help you, here is the above list with the orbitals included. Recall that each blank represents an orbital. All right, so what they're reminding you, right, is S sublevels only have one orbital, P sublevels have 3 orbitals, D sublevels have 5 orbitals, and F sublevels have 7 orbitals. Note that D and F sublevels appear to be out of place. This is because they have extra high energies. For example, the 3D sublevel has a higher energy than a 4S sublevel, and a 4F sublevel has a higher energy than a 6S sublevel. Okay. When electrons occupy orbitals, they try to have the lowest amount of energy possible. This is called the Aufbau principle. An electron will enter a 2s orbital only after the 1s sublevel is filled up, and an electron will enter a 3d orbital only after the 4s sublevel is filled. Recall that only 2 electrons can fit in each orbital. This is called the Pauli exclusion principle. When 2 electrons occupy the same orbital, they must spin in opposite directions, one clockwise and the other counterclockwise. How many electrons would an atom need to have before it can begin filling the 3s sublevel? So we're going to kind of go up here and we want to get into the 3s. So 2 electrons, 4, 6, 8, 10 electrons. So how many electrons would an atom need to have before it can begin filling? It would be 10. The 11th electron would go in the 3s sublevel. B. What is the first element that has enough electrons to have 1 in the 3s sublevel? Use your periodic table. So if I have 11 electrons, because I have a neutral atom, remember that means I have to have 11 protons. So I'm looking for the element on the periodic table that has an atomic number of 11, which is sodium. How many electrons would an atom need to have before it can begin filling the 3D sublevel? So here's 3D, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 20 electrons. So it would be the 21st electron that goes in a 3D sublevel. So if I have 21 electrons, that means I have to have 21 protons. So I'm looking for the element with atomic number 21, which is scandium. How many electrons does the element boron have? So here's boron. It has an atomic number of 5. So number 4 says, okay, below are 2 different ways of depicting the electrons in an atom. I have this orbital diagram, right? 1 means I'm in the first energy level, S sublevel, 1 line because an S sublevel only has 1 orbital, 2 electrons to completely fill it up. Second main energy level, S sublevel, 1 line because it only has 1 orbital, 2 lines, 2 electrons. 2p, second main energy level, now the p sublevel, 3 lines because p's have 3 orbitals. Okay. in the orbital diagram, what do the arrows stand for? So notice 2, 2, 1. We have 2, 2, 1, right? The arrows stand for electrons. What do the little superscripts stand for in the electron configuration? They also stand for electrons. Both of the diagrams represent the same element. Name the element. Well, I have 2, 4, 5 electrons. It's a neutral atom, so I also have 5 protons. And the element that has 5 protons is boron. So this is the element boron. For each of the following electron diagrams, decide whether it is an orbital diagram or an electron configuration and name the element. So this is one like this. So this is an electron configuration. And the element is, to figure out the element, I'm going to add up all the superscripts because that's how many electrons there are. So 2, 4, plus 6 is 10, 12. Plus 4 is 16 electrons, which means I have 16 protons. And the element with atomic number 16 is sulfur. So this is sulfur. This one is like this. So this is an orbital diagram. And the element is, again, I'm going to count my electrons, 2, 4, 5, 6 electrons, which means I have 6 protons. Again, the element with atomic number 6 is carbon, so this is carbon. This also is that orbital diagram. 2, 4, 5, 6, 7 electrons, which means I have 7 protons. 7 protons means atomic number 7, that is nitrogen. This one also is an orbital diagram. 2, 4, 6, 7, 8 electrons, which means I have 8 protons. Atomic number 8 is oxygen. All right, Hund's rule. Look at the orbital diagram from question 5b. Hopefully you identified the element as carbon. The following diagram has 6 arrows just like carbon's from 5b. But this is technically wrong to put the electrons like this. Electrons like to spread out when going into p orbitals. Look again at oxygen's orbital diagram from question 5d. The following diagram is a wrong way to draw oxygen's orbital diagram. Again, it is technically wrong to put the electrons like this. Electrons like to spread out when going into p orbitals. This is correct. Electrons like to spread out when going into p orbitals. They also try to spin up whenever they can. So this is correct. When the electrons have to occupy the same orbital, they will spin in opposite directions. So if I have 2 in one, they have to spin opposite directions. And this is saying if I have one by itself, I should have it spinning up. And I should be filling them all up before I start to put more in any one. So question number 6 says, Hund's rule is the name of the rule that summarizes the above information section about electrons. Which of the following is the best statement of Hund's rule? A, electrons prefer to pair up to occupy the same orbital whenever possible. Or B, whenever possible, electrons will be unpaired or in separate orbitals with parallel spins. They like to spread out, so they like to be unpaired in separate orbitals with parallel spins. Number 7. The following orbital diagram is drawn incorrectly. Redraw it correctly. So, I have 1s, 2s, 1s, 2s, 2p, 3s, 3p. So, right, that is the right order because that's listed here, right? It should be 1s, and then 2s, and then 2p, and 3s, and 3p. So order's okay. S's have 1, so 1 line's good. P's have 3, so 3 lines are good. All right. Paired and full, paired and full, paired, paired, paired and full, paired. So what's wrong here? It's that I have that empty orbital, right? This should be 1s with the pair, 2s with the pair, 2p, all paired up, 3s paired up because I have to completely fill it before I get to the next orbital. But when I get to my 3p's, there's 3 electrons, so they should be all by themselves in separate orbitals, all spinning up. So this is what it should look like. Each of the following above are orbital diagrams is incorrect. Redraw them correctly. So let's first check the order, right? So 1s, 2s, 2p, 3s, 3p. So that looks okay. 1 orbital, 1 orbital, 3 orbitals, 1 orbital, 3 orbitals. So that looks okay. Full, full, full. Uh-oh. Right? I can't put electrons into this P, 3p, until this 3s is completely full. So this one, right? So far that's okay, but when I get to my 3s, I have to completely fill my electrons. And I want to make sure I still have the same number of electrons. 2, 4, 6, 8, 10, 12, 13 electrons is what I should have. 2, 4, 6, 8, 10, 12. So here's my 3p, and there's electron number 13. So order again. And again, we should be using your periodic, eventually you're going to use your periodic table to do this. You won't have to have this memorized. But we have, right, 1s, 2s, uh-oh, right, this 2p is going to be out of order. It should be there. And then 3s, and then 3p. So that's going to be what's wrong with this one. So to redraw it, 1s, 2s, 2p, okay, and we should have 2, 4, 6, 8, 10, 12, 14, 15, 16 electrons here. Okay. Then I'm going to have my 3s. So I'm at 2, 4, 6, 8, 10, 12. So then I have my 3p with 3 lines. I'm at 12, 13, 14, 15. There's number 16. That's what that one should look like. 2, 4, 6, 8, 10, 12, 14, 15 electrons for this one. Again, 1s, 2s is good. 2p, 3s, 3p. So order's good. S's have 1, P's have 3, so that looks good. Oh, here's what's wrong, right? How are they supposed to spin? They're all supposed to spin up. So 1s, 2s, 2p, 3s, 3p, up, up, up. All right, translate the following electron configurations into orbital diagrams using arrows. So really, right, all I have to do is 1s, 2s, it's going to be 3 2p's, a 3s, and 3 3p's. 2 electrons in my 1s, 2 electrons in my 2s, 6 in my 2p, 2 electrons in my 3s, and now 2 electrons, but they're going to remember, because of Hund's rule, they have to go in separate orbitals, both spinning up. All right, my next one, 1s, 2s only has one orbital, 3 2p's, 1 3s, 2 electrons, my 2s has 2 electrons, my 2p has 6 total, my 3s has 1. 1s, 2s, 3 2p's, up and down, up and down. Now p's, 1, 2, 3. So I have to, Hund's rule says I put 1 in each before I double up, but I need 5, so that's 3. Here's number 4, here's number 5. Number 10 says, look at the electron configurations for question 9. Write the name of each element, right? So this has 2, 4, 10, 12, 14 electrons. What element on the periodic table has 14 protons? Silicon. So this is silicon. Because 14 protons means it also has 14, or 14 electrons means it also has 14 protons because it's a neutral atom. So 6, 8, 10, 11 electrons, which means 11 protons. Atomic number 11 is sodium. So this is sodium. Letter C, 2, 4 plus 5 is 9 electrons, which means I have 9 protons, which means I'm looking for atomic number 9, which is fluorine. Question 11. Write electron configurations so no arrows required for the following elements. The first one is done for you. So to do that, I have to look at my periodic table and decide phosphorus has, right, 15 electrons. So I'm going to start at my lowest energy level. 1s, and it can hold 2 electrons. 2s, and it can hold 2. 2p holds 6 because there's 3 orbitals each holding 2. 3s can hold 2, and 3p then has 3 because we have 15 electrons. So neon has 10 electrons. So I start out in my 1s, and I can put 2 electrons, so that's 2. I go to my 2s next, which can also hold only 2 electrons because there's 1 orbital, so I'm at 4 electrons total. So now I come to my 2p. It can hold 6 electrons because there are 3p orbitals. So if I have 6, 7, 8, 9, 10, it's going to have 6. Aluminum has 13 electrons because it has 13 protons. So again, I'm starting at 1s. I can hold 2 electrons because there's 1 orbital. 2s, I can hold 2 electrons because there's 1 orbital. 2p, I can hold 6 electrons because there's 3 orbitals, so I'm at 6, 8, 10. I need 3 more. 3s can hold 2, so that's 12. So then I come to my 3p, and I only need 1 more. Sodium, atomic number 11. So it has 11 protons and 11 electrons. 1s with 2 electrons, 2s with 2 electrons, 2p with 6 because there's 3 orbitals, that takes me to 10. So next I'm going to have a 3s with only 1. Number 12. The following electron configurations are incorrect. Fix them. The first one is done for you. So it's telling you here, first add up the electrons, and there are 8. So this should have 8 electrons. So again, I start out with my 1s that can hold 2, my 2s that can hold 2, that's 4. So I get my 2p, and I only need 4 more. So what was wrong here was they didn't have their 2p in there. So letter B, 2, 4, 6 plus 5 is 11 electrons, right? Which means it should be sodium's electron configuration. 1s2, 2s2, 2p6, 3s1. So what was wrong here was the 2p wasn't completely full first. Letter C, 8, 10, 14 electrons. So again, I start with my 1s. Okay, my 1s, which can hold 2 electrons. Next I come to my 2s, which can hold 2. Next I come to my 2p, which can hold 6 total because of 3 orbitals, so I'm at 10. So I come to my 3s next, which can hold 2, so I'm at 14. 12. 6, 8, 10, 12. Next I come to my 3p. I'm at 12 and I need 14, so I need 2 more. So we have 6, 8, 10, 12 electrons. Again, start out at my 1s, which can hold 2. 2s can hold 2. 2p can hold 6, so I'm at 10. 3s can hold 2, so I'm at 12. 6, 8, 10, 12 electrons. Number 13. Nitrogen's orbital diagram is this. Nitrogen has 3 unpaired electrons and 4 paired electrons. Define the term unpaired, right? Unpaired is talking about these guys. So the person who wrote this said that unpaired means an electron alone in its orbital. How many unpaired electrons does oxygen have? Well, to do that for oxygen, we kind of need to do oxygen's orbital diagram, right? So oxygen has 8 electrons. So again, first I'm going to be in my 1s. With 2 electrons. Next I come to my 2s with 2 electrons. Then I have my 2p's. So I'm at 4, 5, 6, 7, 8. So how many unpaired electrons does oxygen have? Only 2. And that brings us to the end of that ChemQuest.